Revolutionary talk for revolutionary times. Promoting peace, liberty, and prosperity around the clock. LibertyTalk.fm.
Welcome back to Liberty with Love with Robin Koerner. Some of you may know that I am a trained scientist. Wouldn't know just from all my recent articles and most of my recent radio shows, but I studied physics. And there is one scientific issue that is a particular political hot potato in the United States, and that is climate change. And it seems that most people's opinions on the science of climate change are predictable based purely on their politics. Something deeply wrong about that epistemically, but it is so. Today we're going to broach that subject for the first time with a lady that you may have noticed her name in the news recently. Her name is Judith Curry, and if you have noticed her name in the news recently, it is because she recently became the former professor and chair of the School of Earth and Atmospheric Sciences at Georgia Institute of Technology, and she also is the president of Climate Forecast Applications Network. Judith has written quite a lot in the news as, I guess what would be simply labeled, certainly by her opponents, as a climate skeptic from that position. And I really just want to speak to her today to get a sense of, an honest sense of the state of the field of climate science. So Judith, welcome to the show. Thank you for doing this. I know we've had a difficulty scheduling it. I know you're really busy right now, so I really appreciate it.
Oh, my pleasure.
So, how long since you have left the hallowed halls, the ivory towers?
Well, effective January 1st. The last few weeks have been a wild ride for me, but it's all good, I think.
How are you finding the real world?
Well, I've had one pretty big foot in the real world for about a decade in terms of communicating with the public and interacting with the media, and also with my company, where we try to help real organizations, actual companies, try to solve their weather and climate-related problems.
Right, indeed. And you've written quite a lot in the media, haven't you, for many years?
Yes.
Yeah. So, well, to frame this whole thing, what is where should we start either with the nature of the global warming problem we are facing, if any, and or the sociology of climate science? Where would you like to begin?
Well, how about if I integrate the two things?
Let's go.
Okay. What do people agree about? Okay, everybody agrees that it's warming. And in fact, it's been warming for the past 200 years or even more. Everybody agrees that human activities such as burning fossil fuels adds carbon dioxide to the atmosphere. Everybody agrees that carbon dioxide has an infrared emission spectra, so that makes it a greenhouse gas in the common vernacular. Mm-hmm. Okay. Beyond that, there's not a lot of agreement. I mean, the most consequential issues are whether or not humans are the dominant cause of the recent warming. That's something that's hotly debated.
Absolutely.
How the climate of the 21st century will actually play out. Whether or not warming is dangerous, and whether the proposed cure in terms of eliminating emissions of carbon dioxide is worse than the disease.
Right, absolutely.
So, with the attendant economic costs and unintended consequences. So those are the big issues, and there's a great deal of debate around all of those issues, and rightfully so. This is a complex, wicked problem.
So now, what is it that, let's call them the believers to refer to those who do believe that warming is dominated by human action and it needs to be mitigated as a matter of urgency. What is it they claim there is broad scientific consensus on when they claim there is broad scientific consensus?
Well, they mostly claim, the consensus, that they appeal to authority and claim, well, the consensus means it must be true. But the consensus is really, you don't talk about a consensus unless there's a lot of debate and it's politicized. Most things in physics or chemistry, everybody either accepts them or people are disagreeing and debating. You don't talk about consensus. The word consensus gets invoked when there's a great deal of uncertainty.
Right.
and one side finds it advantageous, to claim a consensus. And so that's sort of what's been going on in climate science. Even the most consequential conclusion from the Intergovernmental Panel on Climate Change relates to the attribution of the late 20th century warming. Mm-hmm. And they state more than half of the warming is extremely likely to have been caused by humans. Okay, now think about it. More than half, something between 51% and 99%. That's a lot of wiggle room. And because they haven't fully accounted for certain modes of natural variability and very longer time things that we could be in the midst of, and the very long time scale ocean circulations, natural variability could be even more important, and humans could be contributing less than half. So we don't know. But even if, the consensus is more than half, but somehow that leads to people thinking, well, it's really 100%, because the climate models tell you it's 100%. 100% is what gets included in all the economic models and so on and so forth. So there's a lot of sleight of hand that goes on in terms of these consensus claims.
Let's just stick on this consensus just a little longer, because it would be fair to say, for example, my field of physics, there is a consensus as to the accuracy of the conservation of energy. I mean, that's an accurate statement. I think what you're saying, though, is if you find a scientific community invoking it's kind of like, they're protesting too much, right? It's that Shakespeare line.
Exactly. I mean, the conservation of energy, that's like established, and nobody talks about a consensus surrounding the conservation. You don't need to.
You don't need to, and that's your point, isn't it? It's that it's a red flag. It's kind of a red flag.
It's a red flag. The community that uses consensus a lot is the medical community, when they have to come up with consensus treatments that people agree to follow if you're going to get reimbursements from insurance and stuff like that. So there's a lot of consensus negotiation in the medical community. But, the uncertainties are huge. It's just that there's a real reason, I guess, in that community, given the structure of medical insurance, where you have to do something like that. There's no particular reason that you have to do that in a field like climate science. We should be
that makes sense.
Fascinated by the uncertainties and celebrating opportunities to debate all this. But that's not
so would you say, Judith, though, that as a factual statement, that the fact that there is a consensus, the consensus that's claimed, does it exist even if it exists for the wrong reason? Does it exist as a politicized position to which most people working in your field subscribe, or does it not even exist? What's the truth of that?
Okay, it's a little bit complicated. A lot of people who carry the label of climate scientist might be an ecologist studying the impact of climate science on ecosystems. They might be working in public health. They might be working in a arcane subfield of geochemistry or something like that. So they're contributing little pieces to the climate puzzle. But at the end of the day, this is really about understanding what's causing climate change. And this is a small segment of the climate science community, the climate dynamicists, that really have, a real vote. These are the ones who are, producing primary research on the subject, or others who are digging deep into the literature. It may not be their primary area of research. So that's what it's all about.
Okay, Judith, this is helpful. We're going into the break. This is Liberty with Love with Robin Koerner. We will be back in just a few minutes. Thanks for being with me. I would like to talk more about the science of climate change directly, but I know we've only got 45 minutes, and we've talked about this word consensus a lot. We've touched on the politicization of the field. Indeed, the politicization is kind of the root need for the use of this word consensus all the time. What is the nature of the politicization of the field? How does that work? And did it affect your decision to resign at Georgia Tech recently?
Well, you have to look back to the late 1980s to understand this. And the United Nations Environmental Program, who was looking for sort of environmental causes and rationales for global government, global regulations, globalization, things like that. And this caught on at the United Nations. And very early in all this, even in 1992, there was the UN Framework Convention on Climate Change. And this is a treaty that even the United States signed, where all the nations agreed to work to prevent dangerous human interference with the climate. Now think back for a minute, 1992, that's a long time ago. And the IPCC had its first assessment report in 1990, and they didn't really find any particular evidence of human-caused climate change that could be distinguished from natural climate variability. So the state of the science was, well, it seems to be possible, but there's no evidence of it yet. But right in that time frame, we already had an international treaty about preventing dangerous human-caused climate change. Mm-hmm. So, I mean, you can see that the policy cart was put way in front of the scientific horse right from the beginning.
Right.
So all of climate change science was directed towards the human-caused anthropogenic component of climate change, with the other broader topics, natural climate variability, solar variability, etc., given short shrift, as we had this urgent policy-driven need to better understand and predict dangerous human-caused climate change. So this really torqued all of climate science in a particular direction, and it also resulted in a massive infusion of research funding into the field. So you had this cadre of scientists who made their reputations by participating in the IPCC assessments, getting massive infusions of research funding, were invited to seats at the very big policy tables, and this is heady stuff. And so these were the elite in our field, the people in charge of the professional societies, editors of journals, or whatever. And you can see how this group of people became very influential. And it became professionally advantageous for the rank and file to go along with it. If you want professional recognition and funding and ease of getting your papers published, you go along with this. So that there's a careerism motive for all this. And at the same time, a lot of people who go into environmentally related sciences have an environmental political perspective. So you have also that feedback into it. Personally, I think the careerism is an even bigger factor than environmentalism, but they're both factors. And so you've seen this little self-fulfilling prophecy of dangerous human-caused climate change emerge from the scientific community. No. And in the United States, President Obama played an interesting role. I mean, here's somebody who, as a president who has an understanding of science and an appreciation of science, and he acted to very much scientize the policies and politicize the science, both of which I think were rather ironic, that you might not see from another president who just ignored science and, okay, yeah, give them their funding, let them do what they're going to do, which is almost a healthier attitude. So here we have it. So,
okay.
A very politicized situation, especially in the U.S. right now.
Now, I hear all of that. It makes a lot of sense. Probably not the first time we've seen it, and it won't be the last. But how do you get from there to what I guess you would call this form of motivated reasoning, motivated logic, motivated evidential analysis that is going on in this scientific community that is turning into, I think, a sincere attack on those who are reading the science differently. Right? I mean, I could just be publishing a paper that I know is going to get me funding, taking advantage of my connections because I'm on the right side of the debate, and not get too upset that my colleague down the corridor has a different view. But I do get upset because he's a denier and he's going to murder all of us through, it's got like that. So is this just is it a mass, groupthink? Did we get there?
There's three communities here.
Okay.
One is the politically active, alarmed group of scientists. These are the ones you hear in the news all the time. Okay. Then there's the vast middle.
Okay.
I've called the geeky middle, in a recent post. These are the scientists who focus in on one little piece of the puzzle and dig in very deeply without paying attention to most of the rest of this stuff.
And you would say these are the scientists who are doing good science for the sake of the science. Is that fair?
Yes.
Okay.
They're not particularly courageous in challenging the status quo, but they're not really paying attention or particularly motivated by politics.
Right.
And then you've got the other group, which is sort of a broad group, and it's hard to stereotype them. But, you can sit there and call them skeptics, but I think that's a misnomer because any scientist who isn't critically evaluating the evidence and challenging the conclusions all the time isn't doing their job.
That's right.
So if you're not skeptical as a scientist, you're not doing your job. But, call them the unconvinced or whatever.
Yeah.
And a relatively large number of people who are unconvinced happen to be in what I call the climate dynamics category, people who actually really understand this, who understand the data sets, who understand the models, who understand climate dynamics. So there's a very large proportion of the unconvinced who I would put in, have expertise in climate dynamics. So this gives more credibility. And then as sort of an add-on to the unconvinced group is people from the broader fields of physics and engineering and mathematics and other scientific and technical fields who say, wait a minute, this doesn't make sense. How can they be so uncertain? I mean, I try to model this simple little system and I'm swamped by the uncertainties. How can they possibly be modeling this complex system with any credibility? So there's a lot of unconvinced people from outside the mainstream of
Yes.
climate science, in these ancillary fields, some very smart people from physics and economics and whatnot. So there's a whole spectrum, but it's the vocal activists on the one side that seem to dominate the debate in many ways, and they're a very small group.
Right. Yeah, and one might say 'twas ever thus, actually. We're going into the second break. This is fascinating, Judith. Thank you for being with me. This is Liberty with Love. My name is Robin Koerner, and we will be back in a few minutes. Thanks for being with me. Stairway Press is pleased to announce the publication of Robin Koerner's first book, If You Can Keep It, Why We Nearly Lost It and How We Get It Back. Jeffrey Tucker in the book's foreword wrote, "We seek to end government as we know it, but that is not the whole of what we seek. We also favour something beautiful. Explaining what this looks like and the rhetorical apparatus that necessarily accompanies this is the greatest value of Koerner's book." Barry Farber, award-winning talk show host, wrote, "Robin Koerner's political, psychological and philosophical rampage through today's America, turning on lights we didn't even know were off, takes more and more of your intellectual breath away according to how high you rated intellectually in the first place." Chris Ann Hall, constitutional attorney and educator, says, "Robin Koerner is a defender of liberty and a true lover of America's constitutional republic. The knowledge that Robin brings to his readers is sure to be instrumental in the restoration of our American foundational principles." If You Can Keep It, by Robin Koerner, published by Stairway Press. Go to ifyoucankeepit.us for your pre-ordered, personally signed copy. This is Liberty with Love. I'm Robin Koerner, talking to Judith Curry, formerly of Georgia Tech, and we are discussing the science of climate change, and I want to get more sciencey now. With your climate dynamicist's hat on, Judith, please tell me, what does it actually mean when we are talking about an average global temperature, or a global average temperature? When temperatures are being put into these highly complex models, what are the main sources of uncertainty in the data that are going in? And how, therefore, are the uncertainties in the outputs of these models perhaps being mistreated by those with a political agenda? So I've asked you kind of a big question there, or a couple of big questions. But let's kind of start at that.
Okay, let's talk about the temperature data.
Yeah.
Well, there's no way that we can measure the temperature of every inch
Right.
of Earth's surface. There's no way we can do it. We can only do it at a coarser scale. There are three ways of approaching getting global temperatures. The first one is from satellites that circle the Earth, and you can infer from their measurements something about the temperatures. It's rather hard to measure the surface temperature over land. There's clouds, emissivity issues, and stuff like that. So the satellites are really better at measuring the atmospheric temperature.
Mm-hmm.
And we also can get pretty good ocean surface temperatures from satellite. But the challenge is that we only have good satellite data since about 1980. The other really good source of actual global surface temperatures is the numerical weather prediction models. Every day they assimilate all the observations, initialize their models, and in this cycle they actually analyze the global surface temperature. And you can create a climatology from these analysis products from the numerical weather prediction models.
Now, just let me make sure I understand that. These, because we were talking about where we're getting the data from to put in models, and now you're talking about the models to get data. So
Okay. The models assimilate data. They assimilate all the satellite data, all the surface observation data.
They're not predictive models.
And then they integrate it in a dynamically consistent way. So if there's a place you don't have observations, the model integration is really filling that in. So that gives you a global surface temperature. Now, the really good data, again, is only since 1980s. So you only have this since 1980. In principle, you can go back further in time, but there's less and less data going into that.
And now the data that goes into that, would they be the kind of data that meteorological offices in developed countries all over the world would be compiling as a matter of course and then turning into weather reports for the evening news?
Exactly.
Okay, that's good to know. So this means, some of those gaps that the numerical models are helping us fill in would presumably be covering parts of the Earth where we simply don't have that sophistication of data collection, like probably in the middle of Africa or something.
Right, or the Arctic Ocean, something like that.
Right, okay.
Okay, now the third type, and this is the one that you're going to be more familiar with, is just the surface weather observations that are all assembled into one big data set and modified and homogenized and whatever they do to it. And out pops a global surface temperature product. And we talked about when there's missing data, the weather models sort of fill it in dynamically. And if there's missing data just with the surface weather observations, they fill it in statistically, extrapolate, and things like that. So of the three, I think the conventional surface temperature analysis is the weakest in terms of methodology and more prone to errors, but it's the only one you have to go back farther in time.
And this, just so I'm clear, Judith, this is the equivalent of basically temperatures randomly distributed, thermometers randomly distributed around the Earth, and we read them all, and then we kind of combine them in some way, right? That's basically what it comes down to.
And the fact that there's like no observations in the Southern Ocean or over the Arctic Ocean, and different centers handle those gaps in different ways. So,
how many? Just so I've got a sense, how many are there? How many of these effective thermometers are giving us data on an ongoing basis around the planet?
There's a big variability of the number. If you go to the Berkeley Earth website, they've really assembled a huge data set of all the surface temperature observations, and they count them. And actually, in the last 2 decades, we've actually seen a decline in the number of surface weather observations going into the analyses. It's a lot. I can't even give you an intelligent number off the top of my head.
Okay, so carry on, because I interrupted. So I think I've got the lie of the land, so to speak. Yeah.
Okay, so there's, significant uncertainty in the details, but I think everybody agrees that it's been warming overall for the last century. It's not monotonically warming. Sometimes it's flat, sometimes it decreases a little bit year to year, decade to decade, but overall trend is warming. So, the temperature records are good enough for us to understand that.
So now this might be a naive question, but it is obviously normal work for a mathematician, for a statistician, to look at all these sources of data, look at the uncertainties on those data, and combine them. And I would expect that it would be core work in climate dynamics to be producing papers that actually state the degree of uncertainty of any predictions that anybody is making. And then people who don't like those huge uncertainty ranges can then put out counter papers narrowing them in support of whatever predictions they may be making. Is that work being done? And when people do that work and come up with these huge ranges of uncertainty, what do those for whom the uncertainty doesn't suit their political agendas, what do they do about it, and what do they say about it?
Okay, the issue is this. There are lots of sources of uncertainty. Mm-hmm. So let's just take the simple temperature, measurement one. There's all the adjustments that you make. There's the actual measurement error. There's a sampling error. All of these kinds of errors go into it, and people have estimated these errors. And frankly, they come up with something that at the end of the day looks too small to me. But, that they do the work, and there are these uncertainty estimates. But I think the real uncertainties are bigger. But that says to me that there's a massive failure in the science.
I mean, if you're getting smaller uncertainties than there should be, then assumptions are being made about how, kind of about the unknown unknowns, right? At the very least.
They're not even considering about unknown unknowns. They're considering a few very specific, well-characterized sources of errors. They don't consider, the real uncertainties.
Which is why the physicists come along and throw their hands up and just look at it and they go, it just doesn't pass the sniff test, right?
Right, exactly. So their uncertainty analysis is constrained by the uncertainties that they understand.
Right. But what about those then? But then there's a big opening here. I'm kind of confused, because if you can see that, why aren't folks like you writing papers pointing out all the failures in the analysis of the uncertainties, or the incompleteness in the prevailing analyses of the uncertainties?
I've written a lot of general papers along those lines. I haven't dug into the actual surface data set.
But there are other people doing that, presumably, no?
Yeah, there are other people doing it. The most of the focus is looking at the corrections that NOAA and NASA have made to the raw data. And they see in certain locations those corrections are huge. And it's very hard to understand what the rationale was for making those corrections. So that's, and it seems some of these, you can understand the need for some adjustments, but some of these, especially when you look at individual locations, the changes are huge and they seem rather ad hoc. So I don't feel that all of that has been adequately documented.
Okay.
And that's what most of the debate is about. Why did they change that? Why does this adjusted temperature look so different than the raw data? I mean, that's the main sort of debate about the surface temperature data record that you hear in the blogs and some segments of the media. They highlight that very frequently.
Now, what about the fact, though, that also, I shouldn't say though. What about the fact also that there have been it's ongoing. Predictive models are predicting, what the temperature rise next year is going to be, or in the next 5 years, or in the next 10 years. Now, we now have outputs of predictive models that have been given to us in the past, and we can see whether actual records, actual temperatures, actual data are within the bounds of uncertainty of the outputs of those predictive models from the past. And looking at that, we can go, those predictive models were good or they were not good. Right? So where do we stand with that?
Here's what the challenge is. The climate models do not predict, in a deterministic sense, the effects of internal variability, the chaotic, like the El Niños, the timing of the El Niños, and the longer-term ocean oscillations. That they show variability that sort of resembles those things, but they certainly don't get the timing right. So defenders of climate models would say, well, we're not pretending to predict those kind of details. We're looking at the longer-term trends, at the overall sensitivity to carbon dioxide.
Okay, so then that implies that there are no data on the kind of timescales that we've collected that we could actually use to test those models then, right?
No, you basically need 100, you need 100 years sort of, or 70 years, something like that, to test the models in terms of the sensitivity. But you can what you can do is look backwards. Okay, you count. There's something called the climate sensitivity, that this is how much would the climate warm if you double carbon dioxide, and then you allow it to equilibrate. Mm-hmm. Well, you can sort of look at the last 100 years and try to infer a climate sensitivity from that. I mean, we've almost done a carbon dioxide doubling experiment, not quite, if you look back historically. And you can infer a sensitivity from the observations. And the climate sensitivity that you infer from the observations of the last 100, 150 years is about a factor of 2 smaller than the climate model sensitivity. And I even think that the sensitivity inferred from the observations is too high because they're not allowing for the possibility of really long-term natural oscillations in the ocean. So I think the true observational value could even be lower than half. But even if, as a starting point, the 20th century record suggests that climate sensitivity is half the magnitude that climate models are giving us. And so that's trying to understand that disagreement is obviously a very important thing to do.
We've only got a couple of minutes left in this segment, and I hope you can answer this in that time. If I understand you correctly, you're suggesting that there may be a completely unaccounted for driver in the apparent response of global temperature to amounts of levels of carbon dioxide in the atmosphere. So you said long-term drivers of, I think you said ocean temperature, for example, right? If I'm a scientist, how can I credibly stand by the output of a model when I know there may just be a massive driver that I haven't accounted for? I mean, I don't even understand how this stands up.
Well, there's a flaw in reasoning. I mean, when I talk about uncertainty, unknown unknowns, people say, well, this is what we do know. Let's forget about that stuff. Let's just focus on what we do know. And they think they know this. Yeah. Okay. And it's just a failure of reasoning, basic reasoning.
So let's be clear. It's the equivalent of somebody dropping their car keys somewhere, and they go to the nearby lamppost and they look for the keys there, and their husband comes out and says, "Did you drop them under the lamppost?" They said, "No, but that's where the light is."
Oh, exactly, and I use that analogy all the time. You're only shining the light on one thing. So, of course, you see something, but there's all sorts of things in the dark that you're not even aware of. So that's what I find frustrating.
Just talking about it to a scientist, with my scientist hat on, it's making me upset, and I haven't spent a career doing it. So I can imagine how frustrated you have been. We are going into the final break, and we will be back in a few minutes. This is Liberty with Love with Robin Koerner. I've been speaking to Judith Curry, climate scientist. So, Judith, we've just got a last, couple of minutes here to closing out the show. What is it that you are doing going forward now that you've left Georgia Tech? What's on the horizon for you?
Well, I'm doing 2 things, both of which I was doing before, but which I will be doing now full time. The first one is I have a blog, Climate Etc., at judithcurry.com. Check it out. Join the dialogue. It's great, fun, very illuminating, many different perspectives. So if you're interested in this debate, check it out. The other thing that I'm doing is I'm now full-time president at my company, Climate Forecast Applications Network. And we provide weather predictions on timescales from days to seasons, and then projections out 5 years to several decades, scenarios helping mostly businesses understand their weather and climate risk and help them come up with some profitable solutions to the things that they're dealing with.
Fantastic. Well, I know you're a very busy woman, and I appreciate the time that you've found for me and this show. Again, if you've enjoyed this show, please check out the archives on libertytalk.fm, libertytalk.fm. And this is Liberty with Love with Robin Koerner, formerly Blue Republican with Robin Koerner, but the new name, I think, much better manifests what we're about on this show. So I don't know. I don't even know. I'm kind of het up, Judith. I'm so frustrated now. I'm like, I thought this was too big a field for me to get my head around, to sit down and do the science enough to even have an opinion. And
But you've got to read my blog post today, because this one's important. It's about the social cost of carbon and uncertainty.
All right.
You'll like this one. You'll like that
I will.
one.
And you're saying that to me on the 17th of January. So if you're listening to the show after the 17th of January, check out the 17th of January blog post on judithcurry.com. Climate, etc. is the name of that blog. Again, this is Robin Koerner, Liberty with Love on libertytalk.fm. I will be back with you all next week. Thanks for being with me.
Thank you, Rob.
Revolutionary talk for revolutionary times. Promoting peace, liberty, and prosperity around the clock. libertytalk.fm.